Alright, I want to explore the inverse cosine mostly through examples here. First of all, the notation for inverse cosine. You could write the inverse cosine function as cos with a superscript of -1 or as arc cos. Okay, so I'll try to remember to do both of those. Let's get started with an example. Determine cosine inverse of 1/2. Okay, so we know that this is a ratio corresponding to the cosine function. In other words, this is the horizontal side of the reference triangle. And so we're trying to figure out what angle has the horizontal side of +1/2. So a horizontal side of +1/2 means we could have a reference triangle in the first quadrant where the horizontal side is 1/2 and the hypotenuse is 1. But also you could have the same reference triangle in the fourth quadrant because its horizontal side is 1/2 with a hypotenuse of 1 as well. Okay, so we have to pick now which angle, this one or this one, involves the least amount of rotation. So rotating from 0 to this terminal side involves that much rotation, and rotating from 0 to this terminal side involves that much rotation also. They are equal rotation. And this is kind of interesting about the inverse cosine function. That's always going to happen. Okay, so they have equal rotation, and when that happens, what we do is we choose the positive rotation as our preference. Okay, because we can only output one angle, so we're going to choose the positive angle instead. So we're not going to choose this guy because it's rotating in the negative direction. We're going to choose this guy. And so hopefully you recognize that this triangle is a 30, 60, 90, where this reference angle is 60 degrees. So cosine inverse of 1/2 outputs the angle not 60 degrees, but the radian measure for 60 degrees, which is pi/3. Inverse trig functions typically are notated by outputting radian measures, not degree measures. Okay? Let's do another example and we'll get quicker at this. Determine arc cosine of the input -2/2. So again, our horizontal side is -2/2. So now we're looking at reference triangles where we're going to the left. And the horizontal side for both is -2/2 and a hypotenuse of 1. Okay, so we need to pick which one has the least amount of rotation, this or this. Well, they have the same rotation, so we're going to choose the positive rotation instead. And hopefully you recognize this is a 45, 45, 90. So we've got a 45 degree reference angle, which means that this angle is 3 pi/4 because we're pi/4 short of reaching pi. Sorry about that. 45 degrees is the same thing as pi/4. And if you subtract pi/4, so you take pi minus pi/4 because you're not quite to pi, you get 3 pi/4. So in other words, arc cosine of -2/2 is the angle 3 pi/4. And you could verify that with your calculator. Just make sure you're in radians mode. If you were in degree mode, you would get 135 degrees. Let's do another example. Determine arc cosine of, let's say, 0. So now the horizontal side is 0. So if your horizontal side is 0, that means you're on the y-axis. So we've got to pick which angle. So it could be this angle or it could be this angle. Again, they have equal rotation, so we're going to choose this one, which is 90 degrees or pi/2. So arc cos of 0 equals pi/2. Okay, let's do another. And again, I'm assuming you know your coordinate plane. and your 30, 60, 90s and 45, 45, 90s. Well, notice we're not using a calculator to solve any of these problems. So determine cosine inverse of -1. So our horizontal side is -1, which means we're over here on the negative x-axis because we're dealing with a hypotenuse of 1. So we can only be 1 unit from the origin. So we're over here. And so I'm looking at a positive rotation of this much and a negative rotation of this much. Again, they're equal. So I'm going to choose my positive angle, which is a rotation of pi. So cosine inverse of 1 equals the angle pi in radians. Let's do one last example. Determine cosine inverse of -2. So now we have a horizontal side of -2. Okay, so I'm going to be going to the left, -2. And I've got these two reference triangles with a hypotenuse of 1. And what you should realize at this point is the leg, -2, is bigger than the hypotenuse. This is impossible. Okay? Because you can't have a leg bigger than a hypotenuse. So cosine inverse of -2 does not exist. Or you could say is undefined. You can't calculate it. Okay? If you type that in your calculator, you will see you get an error. Alright, so cosine inverse of -2 does not exist. In fact, you can imagine that your leg can't be bigger than 1 in any case, or -1. So we can make some conclusions here now regarding, if we look at the function y equals cosine inverse of x, we can make some conclusions about x. So the domain, the inputs to this cosine inverse function, the x values have to be between -1 and 1. They can equal -1 and 1 because we know if the leg is equal to 1 and the hypotenuse is 1, that just means we're on an axis. But it can't be outside of -1 and 1. It has to be within those limits. So that's our domain of this function. The range, what types of angles will cosine inverse output every time? So this is kind of interesting. It's going to output angles between 0 and pi. And so that's because if you're looking at the input being positive, the horizontal side being positive, your reference triangles could be quadrant 1 or quadrant 2, and because they're equal rotation, we're always going to choose the positive rotation. If you're looking at an input of negative horizontal side, you could have a reference triangle in the second or third quadrants. The rotation is equal again. You're never going to choose the negative rotation. You're always going to choose the positive rotation. So your outputs for the cosine inverse function will always be angles between 0 and pi, anywhere up here, because you're never going to choose the negative rotation when you have a tie as far as rotation goes. Okay? So that is it for the inverse cosine function, or the arc cosine function. I hope that makes sense.